Hi, I am Shannon Cappellazzi, the Director of Research at GoSeed, and today we are harvesting corn from our nitrogen timing experiment. So what we have done is we planted two different kinds of clover cover crop here in the fall. We let them grow through the spring, we cut them down about the middle of May, and then we planted corn into them. One of the questions we get from farmers more often than anything is, I see that there's a ton of biomass from this clover. How much nitrogen is it actually going to give to my next crop? So we have grown corn without any added fertilizer, and what we're doing today is we're harvesting the corn. We will take the full stalk of biomass and just the ear, and we'll do a nutrient analysis on each of them. So once we have the weight of the biomass and the nitrogen content, we can then say this is how much nitrogen the corn took up. Another part of the experiment that we did was earlier in the season, we took soil samples right before we planted the corn, and then we did an incubation of those soil samples. And we took measurements of the amount of nitrogen that became plant available throughout the growing season. So we have the timing of that nitrogen, when it goes from an organic form of nitrogen into a plant available mineral form of nitrogen. And then we also have the total amount of nitrogen that the corn took up throughout the growing season that is left over in the biomass. Call this corn wrestling.
Yeah.
Got to get all that biomass in the bag for the weight.
Yep.
8.
And what was the number again?
29.82.
29.8.
So one of the things that I think is really nice when you're doing agronomic research is to try to get an entire mass balance. Nitrogen goes so many different directions in the soil. So one of the things we did was we quantified the amount of nitrogen that was in the cover crop biomass. Another thing is we're quantifying the amount of nitrogen that goes then from that cover crop biomass into the corn. Another thing we're measuring is the amount of nitrogen that comes out of the soil as nitrous oxide. Nitrous oxide is a greenhouse gas that has the global warming potential about 310 times stronger than CO2. The major source of N2O emissions is from agriculture, namely applying more fertilizer than is needed. So one of the goals that we are trying to look at is if we can use cover crops to supply that nitrogen, is there less nitrous oxide coming out? Is there a mass balance of less carbon dioxide equivalents coming from a system where we're using cover crops as a fertilizer source? And part of that is because there's a lot of carbon companies who are interested in selling carbon credits. A lot of farmers have used cereal rye for a really long time. It's been a great way for people to get into cover crops, but now they want to do a little bit more. And if we can add a legume to the rotation, we should be able to reduce the nitrogen fertilizer. And in doing that, we should be able to reduce nitrous oxide emissions and also reduce the energy and CO2 production of making the fertilizer in the first place. And so when you look at the whole mass balance, the life cycle analysis of the entire process, we are trying to understand the full range of both carbon and nitrogen dynamics of using cover crops to supply the nitrogen fertilizer. In particular, legume cover crops, and we've done a lot of work with annual clovers that our producers really like, and so now we are testing all of the agronomic and environmental benefits of using those clovers as a fertilizer. All right, so the next stage of our process, we took all of the biomass, got it in this bag, we were able to weigh it, and now I'm going to weigh just the ears, because that's what we really care about, right? We need that total biomass, so we know the total amount of nitrogen that's taken up, but then we also want to measure how much good corn comes off of it. So on each of the stalks, I'm taking off the ears, taking off the flag leaves, and then I'm throwing Chris the stalk. We are going to take an 8-inch section of the bottom of the corn stalk and do what's called a stalk nitrate test. And that is something that is well calibrated to understand how much nitrogen has been taken up. And we will use that in calculating the nitrogen uptake, which is quintessentially what we really need to know about what that nitrogen timing and dynamics look like for what happens after a cover crop.